Hello again, you sick, twisted weather freaks. Welcome to another fun filled, action packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT, your commander of chaos, your colonel of confusion, your captain of catastrophe, and all around evil scientist from weatherisk.com. And we'll be talking here about This Week in Weather with the potential for a significant major East Coast, or actually, it's not significant, but a major East Coast snowstorm. December 22nd, 23rd, and even after that as well. So let's get right to it. First, briefly, about our current situation. There's the service map for this afternoon with the current storm. And you can see where the primary low is. It's in Minnesota. And you can call it up here. There we go. You can see it's right here. And the problem is your triple point is here and the other coastal low is forming here. There's your cold high. We had some cold air damming. But when your primary low is that far to the west, the coastal low has to come inland. So that's really what the problem has been with this system, why it's not an East Coast system. There's the radar. And you can look how much snow is still falling with the blizzard in Iowa, Minnesota, the eastern Dakotas, Wisconsin, northern Illinois. That's where your primary low is, and that's the problem here with the system. So, and here, look at this. This is interesting. You have two different, it looks like you have two different weather systems here. There's your blizzard with the orange in the Dakotas. You see that there in the winter storm warnings in western Minnesota. And then look in New England, you have your winter storm warnings in central Pennsylvania, New York State, and in northern New England. But this is all the same system. So there you go. And the reason for this, again, remains, and this is how I knew this whole thing was coming inland, when a lot of people were still saying, well, the coastal low might go further off the coast, we might get colder, might be more snow or ice. That was bullshit, and the reason why that was BS was because of this. Let me bring it, you can see what I'm talking about here. There you go. The main is the upper low right here, and this is where your triple point is going to form. And when the closed upper lows in Minnesota, Wisconsin, any coastal that forms is going to have to come inland. It can't be off the coast. So even though the block is still there, this had to form and then go. It was just going to do that. So that's why this is just very, very bad sign when the main closed 500 low is over Minnesota, Wisconsin. I mean, it's great if you're in the Midwest, the Great Lakes, but if you're on the East Coast in New England, it's a problem. All right, let's talk about this next system coming up. Now, this I posted on the newsletter, which again, you can get on the website. It's only $5 a month. It covers the next 3 weeks, and you get this sort of amazing detail. So there you go. And I'll bring up my arrow here so we can see. This here was the this is, let's see, December 10th, 11th. This was the GFS extended, and the European is showing the same sort of thing. And that's what's really gratifying about this is a lot of times the GFS ensemble and the European ensemble are different. But with the recent upgrades they've made in the GFS ensemble, it's actually really good out to 10 days. And I think that's a really nice thing to see here. So you can see here is the GFS ensemble. There's your original West Coast. There's your block and the Eastern Pacific Oscillation, your Siberian Express developing. There's the Greenland block, the NAO. There's your polar vortex in Hudson's Bay. And look at the trough. Neutral or even slightly negative in the Mississippi Valley, and that produces the storm. This here is the European ensemble. You can see the same sort of thing. Again, the two blocking patterns there. Big ridge on the west coast, developing your P&A, really unleashing the Arctic cold behind the system. There's your negatively tilted northwest to southeast trough alignment. And then here, this is the bottom one. This is now for December 28th or 29th. You can see the other system coming in behind this one. So that's the one. Again, there are two systems coming up here, I think, over the next 10 or 12 days. So we'll get to that in a little bit. And then this is more detail. You can see the one for 26 and 27. And this is this was the December 12 European NGFS. And you can see here you go. There's again your EPO block. Both models have that. That's when the ridge extends into Alaska and you get your Siberian cross-polar flow. There's your Greenland block, your negative NAO. There's your P&A ridge, and there's the trough. You see how this one is southern, this much hangs down into the Gulf of Mexico, both of these. This is a southern shortwave. And if the northern one doesn't drop in, this is going to be a Virginia, Tennessee, North Carolina, Maryland snowstorm, not one for New England. But this is December 26th, 27th. We have a long way to go. But again, notice how the southern shortwave is positively tilted here. So the shortwave only can't really turn the corner unless these two pieces of energy phase. And at that point, the models don't show that happening. So we don't know. But again, this is just something for December 26th or 27th. Okay, let's go on here. Now, I posted this a while ago, and then I highlighted it. Again, This is when the European was coming out. This was December 12th. A lot of people saw this and they said, "Oh my God, it's going to warm up. DT, and it's going to be wrong. DT is going to be wrong." Okay. Well, again, here what you want to look at is this is again I posted this on the Twitter page and on the website. And you can see on the Facebook page, you can see here what I was talking about. Now, this was the operational run with the huge upper low into the southwestern states. The flaw of the European model is that it loves to do these systems, overdevelop them. Okay, so enormous ridge here, 60s and 70s for Christmas, the day before Christmas, the 23rd. This looks really bad, but look at the ensemble. You see how different it is? Totally different situation. And as a general rule, the operational model should match the ensemble. And when it doesn't, that's a warning sign that the operational model is bogus. You're not going to have the operational model is not going to be right against the European. It just isn't. Especially when the European has 50 members. It just isn't. That's why, you use this stuff. It matters. So, don't overact when you see the operational model. The ensemble mean just kicks its ass, and it always does, beyond 4 or 5 days. Now, there are meteorologists out there which incredibly say, I don't know how to use the ensembles, I don't use them, but they're morons. They don't know what they're doing. So and this is why you want to use the ensemble mean. Okay. And of course, if you look at the surface map, look at this. Look how disastrous this was. Again, this is the operational run on the left-hand side. There's the surface map. There's the warm air storming northward, the snow in Minnesota and the plains once again, and then big rains in the Ohio Valley, the East Coast. Warm temperatures look terrible. And this was the one for December. That was December 12th. This was December. This was This was the 12Z run for December 13th. Here is the one for on the 12th. The same sort of thing. All the snow and the cold is up in the Great Lakes. Big rain and wind the East Coast. Again, wrong. And you can even see there, just the European. Now, this map here from Pivotal Weather, the great thing about this is that you can see the cold air coming in behind it, the 1056 millibar high, another one even further north, very cold. But this is bullshit, not correct. Okay, so you have to look at the pattern. And the ensembles matter. They just do. So here we go. And you can see what I'm talking about. Now, this is, let's take a look carefully. The top left is 0Z December 12th. And that is, I believe that it was Sunday. And you can see here that a couple points here. First, look where the block is in Greenland. See, it has some orange here, which is, a positive anomaly, but it's pretty weak. You see that? And sure enough, because it's weak, look where the 500 low is. It's James Bay, Canada, north of the Great Lakes. This is a pure Midwest New England storm, if this is correct. But it's not correct. Let's look at the updated version. Now, this is December 15th. This is from this morning, okay? Thursday morning. And you can see here, look what the block is. Massively different. Look at the difference between this and this. And sure enough, what happened to the 500 low? It's not in James Bay, north of the Great Lakes. It's in Ohio, moving into West Virginia. Totally different situation. And look how much stronger it is with the negative anomaly. Look at this. Look how much stronger it is down here. Totally different situation. Okay? So, there you go. That's an important feature. Okay. I just want to show you how the pattern evolves, how you have to watch the pattern and see how it evolves and see the significance of the Greenland block. It's hard to underplay. When we talk about having a block in Greenland and Northeast Canada is really, really good for East Coast snowstorms, this is what we're talking about. Okay. Let's look at our teleconnections. Okay, we use them, go week to week and to see the patterns going on. I've posted this before. The red line shows the two North American or Eastern teleconnections. To the left, we have the two Western teleconnections, the EPO, the PNA. And there are, of course, a lot of combinations. So we look up here, we can see the AO and the NAO, all these different possible combinations. Ideally, for East Coast snowstorms, you want this, negative and negative. Ideally, you want to see that, okay? Negative Arctic oscillation, negative NAO. On the West Coast, there's the PNA and your ridge EPO. Again, what you want to see is a positive, you want to see a positive EPO with a negative, this should be negative here, a negative EPO. That's what you want to see. That's the ideal situation. Okay. And that's what this points to point out again. Ideally, what you want is a negative EPO. That means the Alaskan ridge is there, the block, which bringing in Arctic air from Siberia across the North Pole into Canada. Your PNA is your West Coast ridge, and then you have your negative Arctic oscillation and the negative NEO in the Greenland block. So if you look at our teleconnections, what's going on here? Well, let's see. This here is the Arctic oscillation. It stays negative all the way through to Christmas. And then the red dots is the operational GFS. Here you can see that, which is a piece of shit. It just brings it up to positive after Christmas. None of the other models do that. They kind of bring it to a little bit up from being extremely negative, but they still keep it negative to January 1st. Only the operational GFS does that, so keep that in mind. The North American oscillation, here's the Greenland block. They all have it being generally negative. Okay? And again, the operational GFS, more neutral than anybody else. But they keep it negative right through January 1st. That's great. On the West Coast, here is the Eastern Pacific oscillation. You can see it's extremely negative. See, there it is right now, December 15th. See the black line? That's where it is, extremely negative. Then it rises toward neutral by after Christmas, even going slightly positive. On the other hand, the P&A, which has currently been negative, goes positive. We get a ridge on the West Coast. So even though we lose the Alaskan block, we get the West Coast ridge. So it's kind of a trade-off there. Now let's take a look at this. I posted this from December 14th, yesterday, on my last call outlook on the medium page. You can see that the European is really jumping on this, but again, it has too much low energy in the primary low. Let me bring this forward here. So you can see it here. Notice that look at the high here, 1055 millibars. There's the Arctic high that comes down, and you can see with the primary low, the cluster, the secondary low here, and then it really bombs out. The secondary low dies off very quickly. It really bombs out. That was the European. Reason why I was getting excited about it. Again, this here was the 18Z GFS from Wednesday afternoon, and again, the same sort of thing. Primary low, secondary low. Look at the Arctic high in the Dakotas, and then it takes off and consolidates. Okay. Somewhat consolidation. It's not a huge. The red, in case you don't know, you see all these red lines. I'll bring this forward here. You see all the red lines here? They represent areas of low pressure. See that? And the blue represents high pressure. So we have a cluster in this area. It's not really tightly clustered, not that much. It's indicative that there's something there that got potential. We'll watch and see what's going to happen here. All right. Now then came this is the European model from this morning. And it came in and it went bonkers. Just bonkers in terms of what this was showing here. Okay, this got me very excited here. There's the primary low on the afternoon of December 22nd. There it is. Okay, there's the secondary low developing. Primary low is now dead. It's just an isobar. The thing consolidates rapidly by the evening of the 22nd, and then it moves up slowly by the morning of the 23rd, moving very slowly. That's not a lot of movement in 12 hours, just bombing the hell out of the entire East Coast with a monster snowstorm. Really a big deal. Here is the operational GFS from midday. Look at this baby. This is from today. Okay, so this just goes absolutely ape. Look at this sucker. Okay, intensifying low, a huge amount of extremely heavy snow, west of North Carolina, northeast Georgia, northwest South Carolina, if you can believe that, all of Virginia and Maryland. This is as of Friday afternoon, December 23rd, so it's a little different time frame, but it's the same idea. This is the afternoon of the 23rd. This is the evening. Look at this monster heavy snow from Raleigh to Richmond to New York to DC, well, just south of DC, maybe Annapolis, Salisbury, Maryland, getting crushed, southern New Jersey. But this thing is just cranking. It's just getting started. Look at this low. It moves very slowly. There it is near Hatteras. Very slowly here east of Salisbury. And then if we continue on up, the snow is still falling back. If you look at this, the snow. Look at the snow shield running heavy northeast winds from Boston down to Richmond and Norfolk. See that? You're still getting it. See that? Right through New York City and DC and Salisbury, Delmarva, and it's still cranking on Christmas Eve, the day. Look at this monster storm. I can't even see how deep that sucker is. 980, maybe 960 millibars. I mean, if this is right, this is a blizzard. This would be a blizzard from Richmond to Boston. That's what this says, if this is going to happen. Now, I'm not saying that's going to happen yet, but that's what that is showing. It's a blizzard. Look at these winds. Unbelievable. Okay, so there you go. And then look at the snowfall map. Now, this is a Richmond to Boston snowstorm. That's what this is. If you look at it primarily, notice the heavy, heavy snow. See the dark blue? Doesn't get into DC on this. Doesn't get into Philly. They get some snow, maybe to New York City. But and you can see look at the map here. This is what the map is showing. Okay, 12 to 18 inches in central Virginia, only 8 in DC, 20 inches in Salisbury into Atlantic City, and then again in Boston and Cape Cod. New York City, 8. Philadelphia, 8 or 9. DC, 8 or 9. Charlottesville, 10. Roanoke, 8, 10. Again, Norfolk gets pounded. 16, 17 inches there. Now, that's what that is showing. I'm not saying that's correct, but that's what that's showing. Now, let's look at the GFS ensemble. The GFS ensemble, same sort of thing. It goes bonkers, just bonkers. Nice low developing here, off the coast. Perfect track for an East Coast snowstorm. Perfect track. Couldn't ask for anything better. If you look at the ensemble members, here we go. Again, we look at the red lines, we red numbers, we want to see what they're looking like. And again, you can see how the red lines are very clustered here. See how they're clustered in the area? A big East Coast winter storm. Perfect track for everybody. Just a matter of finding out who's going to get the big one, who's going to get not. Who's going to get like 5 or 6, and who's going to get a foot. That's what we're looking at here. Now, this here is the early morning European from early on this Thursday morning. Now, what the European is doing first, let me show you something here. Look at the high pressure here, 1060 millibars. See that, folks? 1060 millibars, monster Arctic high. Look at these howling north winds. The primary low goes through Missouri, Illinois, into Indiana. The secondary low is here. Now, this is not correct. The model is trying to play catch up to the upper air pattern. Okay, it's not correct, but the European is showing this. Okay, again, the reason why we know it's not correct because earlier the European was showing us this bullshit. All right, it's not correct. It's playing catch up to the pattern, trying to understand what's happening with the upper air pattern of the Greenland block. All right, then from there it consolidates it into one big humongous storm. All right, now this has rain in Norfolk and Salisbury into Philly and New York, maybe to DC, but just west of there, it's snowing in Richmond and Charlottesville, getting pounded. Hagerstown getting pounded, and then Reading and Allentown, but Philly's gotten over the rain. Baltimore's on the edge, northwest of Baltimore, it's snow. Look at New York City. This says New York City goes over to snow. So does Boston, Cape Cod, Long Island. 971 monster storm in the Delmarva. All right. Then look at these winds, all right? Oops, look at those winds. Then look what happens. Consolidates, it goes up into central New York State. This looks like the January 1966 blizzard. That's what the European is showing. Now, it's just a solution. I don't think it's the final solution. I don't think it's correct. No, so it's just an idea. Yes, a big storm. Yes, a big storm, okay? Look at the European for the snowfall here. This is Kashera. 24-hour increments. Let's see, 23rd. You can see moderate snow in central Virginia, D.C., Baltimore, several inches. The big snow up to the north. This is the 12Z run here. This is the 12Z run. Okay, this was the 0Z run I just showed you. That was the 12Z run. And then this was you can see New England, the big snows in New England. If we look at the 12Z run, and just show you what the European is actually doing at 12Z. Did I post the 12Z European? I don't think I did. Let me see. I have to actually update that. Oh, I didn't. Okay, that was the 0Z run. 12Z run is showing the same sort of thing. So it's still very aggressive with the whole system, the whole situation. So in fact, let me take a look-see here and call it up on another site that I can see very nicely and see what it's doing here with the European on this. Yeah, it's call it up here. Make sure I got it right. So it's doing the same sort of thing, that I'm sure. And unfortunately, my interconnection is really slow here. So, okay, let's see here. If we can, nope, still running incredibly slow for some reason. Everybody here in Virginia will see on the internet. Yeah, it still has the same concept. The 12Z run. Yeah, that's what I thought. That's why I thought this was the 12Z run. So again, you see two separate lows merging into one, into a humongous storm. Okay, and it's just very impressive system. Just a really, really impressive system. And this is the 12Z run, and you can see the snow. Like I said, posted that. Areas up in New England. Now, what's going to happen is let's take a look at why this is actually happening here, and this is important. Okay, so really, really pay attention to this. All right, so at this point, you can see here's the 500 low. Now, a couple of days ago, it had it up in here. Now, what's going on? Why is it diving underneath it? It's diving underneath it for this system. This here is your 50-50 low. I've talked about this before. This is today's low in New England. It's right there. It's stuck underneath the block in Greenland. See that? That is today's low. That's hitting the mid-Atlantic and New England. December 15, 16 goes up into southeastern Canada, gets trapped there. See, here it is even later, December 23rd. It's still there. There's the blocking pattern. So this is a Rex block. Low is underneath the high. Rex block, Rex block. That forces the system to go underneath it. Okay, that's why it's diving. The other thing that happens, look at the ridge developing on the west coast. As this ridge develops, this is forced further to the south. So only a couple of days ago, the European was showing, let me call it up, you can see it, was showing this. Okay, you can see now what it's showing is it's diving it way to the south. Let's look at that 500 low for 1 second. Look how much further south this goes. Again, this is the early Thursday morning European. You see what it does? It's in Tennessee. The 500 lows in Tennessee, not in Michigan, not in James Bay, Tennessee. Okay? Yeah, that's a big deal. That is a big freaking deal. Having a negative anomaly of this extreme that far south, that is a big freaking deal. And then you can see it here. Now this is the 12Z run. It's doing the same sort of thing. Again, look at the ridge explode here on the west coast, driving the system negatively tilted. Okay, this is a negatively tilted 500 low. You can see it running here from Minnesota, Wisconsin down towards Memphis, Tennessee. That's a negatively tilted, diving for the east coast of the United States, diving for Tennessee, the Carolinas. This is a big deal. And if we look at the GFS here, this is the 12Z GF, 18Z GFS, and you can see, look at the Arctic high, 1055. Again, the primary low is here, very weak, not a gigantic low in Minnesota like we saw with this system today and yesterday, not up in Minnesota, not Wisconsin, a weak primary low in Kentucky. There's the coastal low taking over. Look at this thing go kaboom on the 18Z GFS by Wilmington, North Carolina. The initial low and the secondary low is here off the Delmarva coast. This thing just pulls in the cold air. It goes to bonkers, and then look at this monster. I mean, good googly moogly. Good googly moogly, boys and girls. This is a big deal. And if we look at the 18Z, there it does. Again, there's the initial low. The second piece of energy comes in. Let me call up a good line here. Oh, there we go. Okay. And you can see it. There it is right here. Okay. And there's the big Arctic high. There's the enormous high, the northern neck of it to the north. See that? There is 1052 millibars. Okay, the primary low is filling. Initial band of moderate to heavy snow, Tennessee, Kentucky, northern Mississippi, northern Georgia, Ohio. The coastal low takes over. Okay, and then this thing just goes to town. Look at this monster snow down to the North Carolina, Virginia border, all the way from Boston into New York State, Pennsylvania, Maryland, Virginia. Just, you know, and then if you look at the snow map, there it is on the snow map. Wow. Doesn't suck. Doesn't suck. All right. So, there we go. Sorry for the delay, but this is a big video, a lot to talk about. I'm excited. I am. Okay. I'm excited that the extended models can see it. I'm excited that I detected the pattern correctly, the significance of the Greenland block. I'm excited about the system after this one, December 26th and 27th. I didn't even get to that, so one thing at a time. And this is a big deal for Christmas. A lot of people are traveling. A lot of people have plans. You know, people don't be plowing this stuff 2 or 3 days before Christmas. You know, people going to the malls for last minute shopping. If you're on the East Coast, you won't be able to do that. It's not going to work out for you. It just isn't, boys and girls. So, you know, make your plans accordingly. This is meteorologist DT from Weather Risk. I'll see you over on the Twitter page, on the Facebook page, and on the website.